Everyone, welcome to this session number 351, and today I will try to solve this problem. It's the daily challenge. It's the flip equivalent binary trees. The topic is binary tree, and this is the problem here. Okay. Okay. For a binary tree T, we can define a flip operation as follow. Choose any node and swipe the left and right child subtrees. Okay, a binary tree X is flip equivalent to a binary tree Y. If and only if we can make I don't understand this. For a binary tree, we can define a flip operation as follow. Choose any node and swipe the left and right child subtrees. Okay. Binary tree X is flip equivalent to the binary tree Y if and only if we can make X and equal to Y after some number of flip operations. Given the root of the binary tree, root 1 and root 2, return true if the two trees are flip equivalent or false otherwise. Okay. This is the tree 1 and the tree 2. In this case, the first child left and right is swipe, and basically are true, still in true. Now go to the next level, and basically is okay. I think that I need the middle for validate this. Okay, I think that it's a good size this. Okay, now basically we need to return true if we can if both trees are equal, you know. I think that the values okay, before to start with this logic, let me check the constraints. The numbers on the node in each tree is the range between 0 and 100. Each tree will have unique nodes, but okay, this is I had this though. What happened yeah, bro. I study in the morning and the afternoon. Yeah. But well, in this case we have this problem. The idea is that return true if are equivalent and false in other ways. And basically the rule that we have here is that you can change this, oh my gosh, this swipe with the right, yeah, or for example this with this. Do you imagine that we have 1, 2 and 3, yeah? The operation is flip, basically swipe these elements, like this is moved in this side and this is moved in this side, yeah, and it's exactly the same the first flip here, you know, change the in the tree 1 have the 2 in the left side, and we need swipe for transform this, and this is sorry, this is 3 and this is 2. Okay, now okay, now until this point we have the right. Okay, I think we can, as a default, we can return true. In every moment here appear one case where it's not possible, like for example here, 17. It doesn't matter if I swipe, this basically is different, it's not appear here, yeah? In this moment I can return true. This is the rule. It happened this case where the node doesn't exist in the other tree, or where swiping the elements no. Okay, here I start here and it's valid, this it's equal this. If in this moment is different, if it's the only node and are different, should be return false. Yeah. Now in the case, okay, now before to continue with the next, I need to validate if we need to apply the swipe over these elements, you know. For example, okay, you have this one. Okay, the black is for this side and the purple is for this side, right? Or the green. I think that is better, the green. Okay, now this is one and one. Okay, now for this side is validate this is equal this. Yeah, okay, you can continue. The next step is you have element in the left. Yeah, in this case have element in the left. Maybe for example, if have here and this have here, is still true because it's basically the first swipe, you know. Here I can consider it that have two variables for every, for example, the variable L it's equal to, that is this, and right it's equal 3, where doesn't exist basically is null, you know. And now in this case is L it's equal 3, right it's equal 2, yeah. And in this case the first point is that if this contains two elements and this only contains one, is false. Is always I will have a pairs, yeah. The result of this operation of the, yeah, in this case one. Always the sum between this and this should be have even value, yeah. In the case, for example, that this is null, well, basically it's 1, 2, 3 is not it's not even, it's an odd value. In the case that this is null too, we have only two values. Oh no, but this is pair. No. This is wrong. In this case is 3, 2. Okay, now how I can validate that. Mm, 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 mm. I think here, if I don't, well, I think that I can use the ifs and validate. Okay, if you have two here, this should be have same. If you have one null in this case, should we have similar one null, and inside them make this validation. Well, this stuff, but okay. Now the next is okay. We have this. We have this. In the case that this is equal this and this is equal this, that is not the case, but do you imagine that here is 2 and 3? This doesn't exist, is 2 and 3. Are equal? Okay, yeah, means that you can continue with the next. Okay, in this case, but you know what? In this moment I lose this. In this moment I have the contact with both sides, but in this, when I am here and I am here, if I am using DFS, basically I can validate this side at least. Sorry, in the afternoon usually I am more slow than the usual. But well, in this case I think that I can start here and I can start here and go to the left. Go to the left. In this case are different. Tell me if you have one idea, please share the idea because I don't have any idea in this moment. Well, I am thinking using a double DFS, but I'm not sure because maybe we can make a DFS in order and save the pair in order before to continue. No, but should be in diffusing and save the pair. What is the U? What is the meaning of U? The tip, I know the tip is basically the label, but the U is the node. Sorry, yeah. Okay. Okay. Yeah, the value, because in this case is the values are unique. In order, but in order means that you go to the this and go to this and is complete. No, yeah. I know, but I am thinking that if I need save the value in the moment where I validate the left. But in this case, if I apply the operation before to go to the left, it's basically pre-order, right? Okay, in this case, the idea is that I am thinking that do you know what? I am thinking that maybe it's not necessary, apply this operation in this. I am thinking that, for example, if you have, do you imagine that a bigger binary tree and you have like this? Yeah, and this is one side and the other side is like this. 2 4 2 4 6 8 2 4 6 8. Yeah. We have this and we have this. Okay, now we only need to know if this pair exists in this side. It doesn't matter the order. It's only remove, because if exists, basically you have the ability to swipe. It's not in this problem. Don't mention that return the number of operation. No. It's only return true or false. In this case, for example, in this, yeah, I think that could work. And I know I don't need anything. Basically, it's only transversal. The first three. Here, transversal this in the BFS, and for example, we have 2 and 3. This is the pair, yeah. And in this side is transversal pairs by pairs or node by node, parent by parent. In this case, is 3 and 2, and basically search this element or this pair appear here. Yeah, remove it, and in that the final, this list is empty, means that we can swipe, or maybe not, don't swipe. Yeah, it doesn't matter the order here. And with this, basically, for example, here, yeah, I think that I can resolve with BFS. I am checking your comment. One moment. Before to check your answer, I would like to develop a little more this approach. But for example, in this level, that is the more is the heavy level here. Yeah, you have the first pair is basically 4, 5. The next pair is 6 and null, 6 and null. Okay, and now in this side, the first pair is 6 and null. And even I can sort this element in the order, in increase order, yeah, for keep simple the compares, for example, in this case 4 and 5, 6 and null, and here is in this case 6 and null, and this is 4 and 5, 4 and 5, and basically is okay, this is contained in this list. Yeah, okay, remove it. Now this is contained in this list. Yeah, remove it, and then the final is empty. In the moment that I transversal this list with these pairs, this list of pairs, in the moment that I transversal or completely in this contain elements, or in the case that I am transversal this list and I don't have more element in this side, means that it's not possible have an equivalent tree, because you have more or less nodes or pairs than the other. Make sense? I don't know if makes sense this approach, but basically this is idea. And obviously for avoid that the operation in linear time of the list, because when you are searching in the list or you apply the contains, and this operation is in linear time. But if I save this element in a hash set, yeah, as an string, isn't constant. I can reduce a little bit the time complexity here. And I think that is the same with here, with this. And even more because are unique the values, means that I don't feel, I don't be care for the duplicates, you know? But well, I think that this is my approach. Your approach is different, right? I think that, let me check very quickly your answer. Then bro, your answer always are the the best performance. It's a crazy. in my yeah, in my side I am here. But well, let me check. If yes, my gosh, but you have this go again to the left. This the level flip equivalent. Okay, let me check my solution. Makes sense this, but let me check my solution. I think that this could works. I'm not sure if it's much better or much worse. I think that is worse. But let me check. How many years? I think that years. But how many years do you have programming, with the DCA and these stuffs? Yeah, basically it's this. Save the pairs. A pair can have, for example, null and null, or number and number, or number and null, whatever. But in this side is the same. And even let me check. For the all number are positive, I have by default, if doesn't exist, if it's null, I can put less one, in this. Okay. Oh, bro. Yeah, you are very, very good in DCA. I would like to start with the competitive programming, but I don't feel with the skill. I don't feel that my skill is enough for this. This is the another level. I don't know how to say that, but the Grandes Ligas. I don't feel with enough skills. But well, at least I am trying. Okay, now here, the first is that we need a hash set for save the strings. In this case, a string. Yeah, I think that is more easily with this string. And this is set 1, it's equal new hash set. And I think that I need another, name it no, not only one, it's only one. Now here it's basically what is that? This is BFS. In this case, BFS is a Q. Tree node Q it's equal new linked list. And now in integer size is equal q dot size, and I think that it's enough with this. Now here is q dot add, in this case is root1. Oh, but I need to do this operation at the same time. Okay, here I need another q, q1, q2, this q1 is equal this, and q2 it's equal this. In this case, for example, for the root, I can compare root1 dot val. It's different to root val. Return false. Don't make sense. Continue. In the case that is the same, I can continue. And here it's a while. Q1 is empty. Okay. How is it's empty. Okay, let me first complete the BFS for the first three, and next two I mix with the other. In this case is this integer size 1, it's equal q dot size, yeah, and q1, yeah, and here is a 4, and basically it's transversal all this q and add the value in the hash set. Okay, integer I it's equal 0, meanwhile I it's minor to size 1 I plus plus. Okay, and now here is get the no, but here tree node 1 it's equal q dot is removed. Is removed, and it's inside here. And now here is get the pair. The pairs, in this case tree node left 1 it's equal net 1 dot left, and right and now is do this operation to transform as a string. Even I think that I can create a function here, private string get string, no, get I don't know, hash, and in this case receive two values, left and right. Left integer right, and I have this value now is integer temp, no, array it's equal new int new int of the size 2 and integer, no, here left dot val and right dot val, and now is collections dot sort. I'm not sure if it's with collection or with the erase. Let me check. Sort array Java. I don't remember. Erase sort, and basically here is return new string, and the string is a array. Yeah, sorted. But here if I need a few validation here. Integer L it's equal, if left it's equal null, then less 1. Other case this, and for the right is the same. Basically where is null, the default value is less 1. This doesn't exist. It's not possible that exists in the natural form in the trees. Yeah, right, here is right, and here is L and right, yeah, and we sort, and next to is returning this. Now this return a hash, and basically here is set dot add this, and left 1 and right 1. Yeah, and in this case I am saving these values, and basically now is node 1 dot left it's different to null, q dot add node dot left, here is the same, right, okay. Now in this way I am transversal in the BFS this tree. Okay, now the idea is that transversal to this tree at the same time. Okay, I am transversal this in this moment here. Okay, and Q2 is but this is negative. And no, only this. And now where is transversal this, and I fill this element, now is validate that this pair exists in the other tree. Okay, now here is size 2 it's equal Q2. Even in this moment I can start with the validation. If the size either if the size 1 it's different to the size 2, means that are different. It's not necessary to continue with the operation. Return false. Yeah, in this case should be equal. Now it's a 4 integer I is equal 0, meanwhile I is minor to size 2, I plus plus, blah blah blah, and basically it's the same like this. But in this case I will change this for don't confuse with the others. This is Q2 and this is Q1. And here in this moment I need to first is contained in the hash set. Oh yes, yeah, it makes sense, you know, and the final it's only compare the sets, but I'm not sure in Java because Java being Java, hash say sorry, again in the afternoon I am more slow. What? Compare hash sets Java. Because it's okay, I think that I should be use this because if you want to set variable that are both null to be yeah, I think that this, but yeah, good comment. But do you know what in Java the problem with Java is that the string is an object. You can compare like this. This is wrong. You can compare this because the string is an object. You need to use the equal. Yeah, because are object, and again Java being Java. But well, in this case, yeah, it's a good comment. In this case, let me copy this and set 2. But in this case, I'm not sure because, for example, have this different order. Add keep order. I think that I need to use another data structure for keep the order or for sort. Okay, no what is the operation in particular I think that we can use this, right? The sorted set. Because with this, I am sure that both elements will be. Let me check. I never use this. Where? In the operation R. ¿Qué pasó? Oh, add. Yeah, I think that I can use this. Here, and it's 3 set. 3 set. This for keep this. Let me change this for 1. Where is the here? And I think that is basically this, but here. And this is set 2, left 2, left 2, 2, 2, 2, 2, 2, 2, and 2. And here is 1, 1. And here if what is the compare here? Set1, its set2 are equal. I think that in this case return false. In the other case, set1 is equal new is reset, you know. Oh my gosh, it's too much code. Yeah, it's true. Instead, use the string, use the array, you know. But I mean, to solve without hash set. Yeah, I think that works. And I can avoid this problem with the, yeah, I like it. Array. In this, it's an integer, because in this case I am using the defaults. Even I had the idea to use the string, because where the element is null, I have the idea to use the null, but no, in this case I am handling the case where it's null with ls1. And that's it. What do you think? Will work or no? Oh, in this is here. And oh no. Okay, let me, I think that is here. And this return true. Yeah, I think the same. But let me check, I double check, because always I have these dump errors for don't put the right word or this stuff. Even here, instead you only return this, I can return this. Yeah, only for be sure. The graph is empty. But in the case that is empty, is possible. The each tree is unique. The number of nodes into yeah, it's possible. Yeah, could I root 1 it's equal null, and I think that here is where the case where are different is this. Root 1 is null and root 2 it's equal null. No. Yeah, it's possible because it's 0. In the case that are different, for example, one the first is null and the second no, is false, or the value no. But in this case, I need another validation, or root 1 is equal null and this is different, or the other is that where it's in the positive way. I don't like my code, to be honest. I think that I can reduce, but but the first condition if x is the root. Yeah, Yeah, I was thinking in this. Yeah, you're right. And here is or this. Yeah, good eye. Okay, I think that we are ready. Ah, damn. What is error here? What is the problem with this? What? Illegal. Ah, yeah. Now the other is this. Maldito.com. Okay, here. Now. I cannot cast the class comparable. I think that in this case I can compare the. No, but how say that? Compare set. Okay, let me check with this. Maybe it's this and this is the same. What? Here. Set one. Yeah, because the tree map can compare. Well, I didn't have idea. I think that I need come back to the use the strings, because in this case I think that is for this. I can comparable. Yeah, I think that is for this. Oh, damn. Okay, new string. We are go again. Maybe an array list and sort them. But I think that well, I'm not sure. I need to research how works internally this comparator, because I think that is in a deep way, validate all the values. But let me try with the string. And if this doesn't work, I change. It's a bad signal. Okay. Array to string parse string. I'm not sure if only adding I'm not sure if I think this. Well, I need to check here this string air it's equal this and return air. What return this? Because it's memory. Yeah, sure. Res. Okay, now with the book. Yeah. Uh, oh, I think that I am having this problem, but basically it's an. Oh no 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 no! I need sort, and next to the sort, I need to. Okay, I can use the string builder. It's equal new string builder, and is b dot append the first position that is the minor array in the index. Okay, this is before here in the index 0 and separate by a comma. Boom. And here is array in the index 1, and here basically it's only return is b to string. Is b to string, and this is uppercase. Well, at least works with the first and the last. In this case, in this, it's empty, and empty return false, and it's true. Why? Okay, I think that is for my condition where both are null. Where is here? Removing this should be work. What? I remove. It means basically root 1 is equal null. Again, Java being Java. What is the error? This is second, and this is the last. If both are empty, you access the third condition. Yeah, in this case, here is because in this case it's null. For example, it's null, and this is not null. It's not, and in this case it's because both are null. You know what? Root 1 it's equal null, and root 2 it's equal null. Return false and true. But in this case, if everyone is equal and yeah, here is too much code, but damn, oh my gosh, very near. True and false. Why? Yeah. Yeah, here I think that I have a big problem because this, well, this is equal this. This swipe and whatever is the same. But in this case, this they have different parents. And in this case, I think that my code don't work with this case, or can't work with this case, because validate this, now go to the next, and basically I can swipe again. Yeah, 0, 0, 0, 0, 3. But next is, yeah, I think that my work can work with this, because here and here return true, because basically is you can swipe but it's not true, because the parent of this, let me check the rules again. Equivalent flip the equivalent. For example, here. Yeah, my solution is bad, or can't resolve this, because in this case, do you see that always the parent is the same, only change the child's, but always the parent is the same. And in this case, for example, with my code, interpret that is true, but it's false, because the parent in this case, the parent are different. Okay, I feel that I think that I can fix it, but well, I'm not sure. Well, I think that it's enough for this session. Thanks, Joe, for following this transmission, and I hope see you in the next. Bye bye. Saludos.